So after discussion on Kepler's first law and second law, let's continue with the Kepler's third law. And this law is also termed as law of periods, as this law relates the revolution period of a planet in elliptical orbit with the dimensions of its elliptical path. Let's first write down the statement of Kepler's third law. This law states that the square of period of revolution of a planet in its orbit is directly proportional to the cube of semi-major axis of the elliptical path, or you can write elliptical orbit around Sun. And this is the statement, and we can directly state if there is an elliptical orbit in which the planet is revolving around the Sun. Say if there is the Sun and say its semi-major axis is A, semi-minor axis of this elliptical orbit is B, then in this situation say this is the location of planet which is moving with the tangential speed V. And here we can say if T is the time period of its revolution in which it completes one complete revolution in its orbit. And here we can say according to this Kepler's third law, T square is directly proportional to A cube, where A is the semi-major axis of the elliptical path. Here say if we are also given with perigee and apogee, like say R1 is perigee and R2 is apogee of the planet with respect to Sun, then the semi-major axis can also be written as R1 plus R2 by 2, as R1 plus R2 is the major axis. And here there is a proportionality constant which can also be derived. Right now I am not deriving the constant of proportionality as it is out of the syllabus, or you can say out of the scope of this particular lecture. But if you wish, you can go through the physics galaxy part of gravitation, which the whole derivation is given. Yeah, the constant is obtained as 4 pi square by GMS, where ms is mass of Sun multiplied by A cube. So the constant of proportionality is given as 4 pi square by GMS. And we can directly write for circular orbits. We can directly state A is equals to B is equals to R, which is the orbital radius. So we can directly write that T square can be written as 4 pi square by GMS multiplied by R cube. This, if you can recall, in satellite motion we already obtained. For a satellite, this relation holds. Similarly, for a planet in circular orbit, this can be directly calculated like we have calculated for a satellite. But for an elliptical path, this is a standard relation we need to use. And here semi-major axis of the orbit is A. And here one more important thing you need to keep in mind whenever you are required to find total energy of planet in elliptical orbit. This total energy in elliptical orbit is also given as minus G ms m by 2a. This is also a standard relation which you can use. So if at one point you know the kinetic energy of planet, correspondingly potential energy can be calculated by subtracting kinetic energy from the total energy. So these are expressions which are quite useful for mathematical analysis of planetary motion around Sun. And Kepler's laws formulate the most important basis for analytical calculations for planetary motion as well as for satellite motion.